Hey everybody, it's Aaron Murakami with eMediaPress.com and the Energy Science and Technology Conference, which will be coming up for the 10th annual conference this coming July, from July 7th to the 11th. You can go to eMediaPress.com for the books and videos, or you can go to EnergyScienceConference.com for details on the conference, which this equipment is going to be demonstrated at. I'm here with Eric Dollard, and as you know, we've been working on this this audio rack over here for a while. It's mostly complete, just needs some testing, and then we've been busy working on this RF rack right here. And of course, by the time you see this, you'll have seen some of the videos on the this Tesla coil arrangement here. And so what we have here on this RF rack is that we have this whole lower unit down here, which is pretty tight and compact. There's not much space for anything else in there, and Eric's going to walk us through basically what we're looking at down here.
Okay, so this is the rectifier for the high voltage for the vacuum tube plates. So this is its terminal strip. This is where the this will be the plus out, and this will be the minus out, and this will be the plus out, and then there's the modulation inductance ties in. And this is the AC input to the rectifier. There's two rectifiers in here. Each one is 2,400 volts. And then come around here to the front.
And those are the potential transformers that go right here, you're talking about.
Yeah. And then this connector converts from 2,400 to 4,800 series parallel connection, and also shorts out the modulation choke because there'll be no AM on 4,800. The AM will only be on 2,400. So this is the main filter choke here, 4-terminal device, so that quadruples the inductance, and then the filter capacitors are, you can kind of see them from this direction.
Is it the plastic capacitor?
They're buried behind the plastic.
Yeah, right underneath there. There should be other pictures and videos where you can see these better. Yeah. Those are made by the Plastic Capacitor Company, 2 of those.
So then here's the rectifier diode assemblies, and they have the EMP suppressors across the terminals, and they're rated for a much higher voltage than the transformer, so they won't be prone to burning out.
20 kilovolt, 2 amp. I use these same ones on the plasma ignition experiments, and they're pretty rugged. I've never blown one out.
So, and then this is the load resistors to keep the rectifier stable so voltage doesn't climb high. Being that it's a single-phase rectifier, it has bad regulation. So you have to have a dummy load resistor to keep, if they go open circuit, the voltage reaches excessive values.
Okay.
So the problem here, engineering-wise, was how to get this whole thing together without...
Okay, go ahead.
And it was confined to this level of volume in the rack. It couldn't be any bigger other than the plug-in panel, so everything had to fit in this box. Now the problem is with this stuff is it has to come completely apart. You can't cut any wires or be fooling with any stuff. Everything in here has to come completely apart so it can be repaired or modified, and that makes things a lot more difficult when everything has to come apart after you put it all together again, and it has to do so easily. And then the back panel, that still has to be completed with all the power wiring, and then here on the side is the these are the fuses for the circuits, and then these are the terminal blocks for the power coming in the various circuits, and then the main plate contactor is buried in the back here, and that's what switches the big transformers on and off.
Hard to see in there, but that's it right there.
And then the transformers are laying over here on the pallet. You might as well get them thrown in there too.
Okay. So these are the potential transformers here, and both of these are going on a plate, which is going to be kind of suspended up in this area. So if you're looking at it from the front, one will be here and one will be here. And this is basically rectifying that into DC.
And then what's not hooked up is the modulation inductance and the modulation capacitor. So this is the high-pass filter that introduces the audio rack modulation power into the DC power supply so that it adds or subtracts to the DC voltage however the instantaneous waveform of the audio is moving. So this network and its resistors, the plate that goes here, this is all awaiting parts and yet to be assembled. So at this point, most of the metal work is done, other than maybe some terminal strips and what have you. So now we're just waiting on materials to finally button this thing up, and then move on to the next step, which is over here. We have the front panel now finalized for the next panel up, which is the power control panel for the high voltage rectifier tubes and or 5 voltage rectifier and the power tubes that it runs.
So these 4 holes will be for these type of Westinghouse meters, and then
so this will be
variacs.
The control grid voltage on the power tubes. This will be the screen grid voltage, and this will be the plate voltage, or 1/2 the plate voltage, depending upon how the rectifier is selected.
And those will be lights, switches, and fuses. Lights, switches, fuses. 2 more lights. And what's going here?
Another switch.
Another switch.
This is the AM pulse switch selector. And then this turns on, each one of these turns on its various power supply. And then there's 2 variacs that go on either side, the control voltages, and then the modulation meter goes in the middle. Let me go get that. It's a very unusual meter.
So now it's all drilled and everything, and we'll take this to get powder coated, and we'll just keep moving right up the rack.
This meter
unit
is
by
interesting
unit.
in that it has 4 terminals, and it does not have a permanent magnet in it. And that's why the pointer is free to float.
That's going to go right there.
So one coil is for the DC going into the tubes, and the other coil is for the AC going in the tubes. And the 2 currents are always supposed to be equal to each other when it comes out of the network, and then that tells you when they're equal to each other, then the meter goes up to 100%. If there's no audio at all and it's all DC, then that pulls it back down to 0. So I haven't opened one of these things up yet, and I don't want to fool with it, but see, here's the audio current flowing into the vacuum tubes, and this is the direct current flowing in the vacuum tubes. This is a network that extracts that out of the tubes, so that way you kind of know where you're running, because if you go above 100% modulation, it starts to distort. So that'll be the 4th meter in there, and then that goes here.
Yeah, that plate is this tall.
And then the plate behind it will carry the power transformers and terminal strips and meter resistors and all the miscellaneous stuff that goes along with that function.
So it's got the main plate here, then some standoffs and a plate behind it, kind of like this arrangement, but from the front and right behind it.
And then the potential transformers come out here, and then this next section of volume of rack becomes full. So each stage we go up, it's going to be like this. There's not really going to be a lot of empty space in there. In fact, this could possibly even be tighter. So this will be, as is evidenced by this rectifier, this is obviously a very compact and very solidly built unit. This thing can be dropped on the floor, and there's going to be a minimum amount of damage in here. As we work our way up, every time the rack gets stronger and stronger, until it becomes like this, a block of solid matter.